All right, today's lesson is on representing functions. A function is like a machine. You can put values into this machine and it produces a product. So imagine we have a machine here. And we can put whatever number we want and it's going to produce a product here. I'm going to put a little basket here. So let's say I want to plug in 0. I throw 0 in the machine and it spits out 1. And if I were to throw in a 1, it'll spit out a 2. Just what a function does. The values sent into the function are called inputs. The value that comes out of the function are called outputs. So let's say I have 0, 1, 2, and 3. If I'm putting these in the machine, these are going to be called the inputs. This is what I'm feeding into the machine. And what comes out of the machine is called the outputs. Let's say I get 1, let's say I get 2, 3, and 4. These would be called outputs. It's the product of what comes out of the function. The set of input values are called the domain. And the set of output values is called the range. So another way of saying what I had earlier, instead of just input value, I can call that the range. The domain, because that's what I start with. Input values is the same as the domain. That's what I start with. And my output values, that's the same thing as saying range. A function pairs each element in the domain with exactly one element in the range. All sets of ordered pairs that are not functions are called relations. So for example, the function we use, I use the set 0, 1, 2, and 3. And it paired up with the other. When I plugged in 0, I got 1. When I plugged in 1, it outputted 2. I plugged in 2, I got 3. I plugged in 3, I got 4. So each of these elements are paired to a unique element in the other set. We could write it in ordered pair notation. I could write it as 0. You always start with the domain first and the range second. I could say 0, 1. Or I can say 1, 2. 2, 3. And we have 3, 4. And notice that each ordered pair is assigned to a different element. You don't see the same element twice. 0, 1, 1, 2, 2, 3, 3, 4. You don't see 0 repeat twice, or 1 repeat twice, or 2, or the 3. F of x is known as function notation, is read as f of x, not x times x, where x is an element in the domain of the set. The algebraic expression that defines a function is called a functional rule. For example, what I was showing you before. Let's say I had 0, 1, 2, and 3. These are it's my domain, my input values. And I had this machine, but the rule for this machine, let's say, is to add 1 to every number. So I would say x plus 1. And you remember the output values. That'll be 1, 2, 3, and 4. The rule is what changes the input numbers. It says that for every number that you input into this machine, you have to add 1 to it. So the way we write it algebraically, in general, will be f of x, where x represents any number in the set of the domain, is equal to x plus 1. And this will be called my rule, my functional rule. That's what tells the function what to do. Functions are often used to describe a relationship between two variables. The independent variable represents the input value. The dependent variable represents the output value. So I'm going to write what I wrote before, that f of x equals x plus 1. This is my independent variable. Because it doesn't matter what values I plug into the function, it always has to be added by 1. This depends on what this value is. All right, write down the domain in set notation. Write down the range in set notation. Well, the domain is just simply what you plug into the function or the machine, as if you will. So you just put a set, put a bracket, and write it in order. So I'll put 0, 1, 2, 3, and 4. And that'll be the domain. And what comes out of the machine is called the output values, or we call that the range. So you're going to write that in set notation. You put 0, 1, 8, 27, 64. And that's my range. Write the range in set notation. What is the functional rule? Write this in general function notation. All right, the range is whatever I plug into this function. The rule is 3x minus 1. So if I start with 0, I'm going to say 3 times 0, which is 0 minus 1, so I get negative 1. If I plug in 1 for x, I get 3 times 1, which is 3. 3 minus 1 is 2. If I plug in 2, 2 times 3 will be 6. 6 minus 1 is 5. If I plug in 3, 3 times 3 is 9. 9 minus 1 is 8. So this will be the range. That's what's going to go into the box when you plug in those values. And the rule is 3x minus 1. So you're going to write it in general as f of x equals 3x minus 1. It's a general notation for that function. Right, is this a function? Why or why not? So we have f of x equals x squared. I have it in function notation. So think about that. You can pick any values for this because this is the independent variable. So let's say 0, 1, and 2. Let's just try that. So if I square 0, I get 0. If I square 1, I get 1. If I square 2, I get 4. So our range is 0, 1, 4. So you can have 0, 0, 1, 1, and 2, 4. Now, many of you probably get confused because you're thinking that 0 is paired to 0, 1 is paired to 1. That's okay, as long as it's uniquely paired to a separate element in the next set. So the way to check it is to make sure that these numbers don't repeat. You have 0, 1, 2. So yes, this is a function. Is this a function? Why or why not? This is an ordered pair notation. I'm going to write down the domain separately. So domain is the first number in the ordered pair. So I have 1, I have 2, I have 3, I have 2, and I have 1. So we'll part 1, 2, 3, and then see where it pairs off to. So my range, I have 2. I have 4, 5, 6, and I have a negative 3. 1 goes to negative 3. 2 goes to 4. And 3 goes to 5. But now look at this. 1 also goes to negative. 1 also goes to 2. This right here tells you it's not a function because we have a value in the domain that's assigned to 2 elements in the range. Or you can think of a soda machine. If you plug in, you get a Pepsi and you get a Coke, you know something's wrong. You get the different value. So we know this is not a function. Okay, this concludes our lesson for today.